Good day everyone, I'm Rica J. Bautista, a BSIT student. For today's video, our topic is RSA Online Calculator and Elliptic Curve Online Calculator. RSA Algorithm. The RSA algorithm is a public key signature algorithm developed by Ron Rivest, Adi Shamir, Leonard Adelman. Their paper was first published in 1977, and the algorithm uses logarithmic function to keep the working complex enough to withstand brute forces and is streamlined and have to be fast post-deployment. To calculate using RSA calculator, you need to generate public and private keys before running the function to generate. There's a vertex and plain text. They use certain variables and parameters. Once you generate the key, you pass the parameter to the function that calculates your ciphertext and plain text using the perspective key. If the plain text is M, ciphertext equals to me mod N. If the ciphertext is C, plain text equals to CD mod N. To understand the above steps better, you can take an example where P equals to 17 and Q is equals to 13 value. E can be 5 as it satisfied the condition 1 less than E less than P1 Q1. N equals to P times Q equals to 91. D equals to E 1 mod P1 Q1 equals to 29. Public key pair equals to 91.5. Private key pair equals to 91.29. If the plain text M value is 10, you can encrypt it using the formula me mod N equals to 82. To decrypt this ciphertext C back to the original data, you can must use the formula CD mod N equals to 29. You can now look at the factors that make the RSA algorithm stand out versus its competitors in the advantages section. Elliptic curve calculator. Elliptic curve has two scales, red and blue, running in the opposite direction on the elliptic curve. The scales are reciprocal of each other for any point label, x in red and y in blue. Multiply two numbers together, find them ignoring decimal place 10 times, and x are represented by the same point in the same color, and draw or straight line through them. This will intersect the elliptic curve in the third point. Read the result of on the opposite color scales. This is the product of two numbers. This has similar structure to the real number, which means that we can interchange between the two. This is not so straightforward, requiring a transcendental function related to the p function used to repeat that interval bisection and polynomials interpolation to obtain a good approximation instead. An elliptic curve can simply illustrate as a set of points defined by the following equation. Y raised to 2 equals x raised to 3 plus ax plus b. Based on the value given to the a and b, this will determine the shape of the curve. Elliptical curve cartographic uses this curve is over-defined field to create a secret that only the private key holder is to able to unlock. The larger the size, the larger the curve, and the harder the problem is to solve based on the value given to point A and B. An elliptic curve is drawn. A line can be drawn through these points until it reaches a third intersection point on the curve, which we can call point C. At this stage, when the line reaches its intersection point, we can reflect the point on the other side of x-axis continuing from point C. We can then draw a line through from the point to point C, which intersects with another part of the curve point D. This point is also reflected to the other side of x-axis, and this process continues until an endpoint is defined. Each intersection point is defined in terms of a dot. The intersection point would be described as A dot A equals to B, A dot B equals to C, A dot C equals to D, and lastly, A dot D equals to E. The number of the intersection point isn't unknown to those without the private key, thus making it very difficult to create the number of times the equation was dotted.